Please feel free to skip to this point in the video. If you don't, feel free to carry on watching. So a logic probe is normally used to test integrated circuits.
By the way, do you hear the audio of the video?
Yes,
ma'am, madunggan naman.
Low means there's no voltage, and in some logic probe cases, pulse, which normally denotes that there's data passing through. As we can't see what's going on inside the chip to see if it's working, for today's purpose we'll be using this LED. Because when the Arduino pulls the pin high, the LED lights up. When the Arduino pulls the pin low. In today's video we'll be looking at how to make a simple logic probe. If you already know what a logic probe is, feel free to skip to this point in the video. If you don't, feel free to carry on watching. So a logic probe is normally used to test integrated circuits. And specifically, if the pins on the circuits are high, which means there's voltage, low, which means there's no voltage, and in some logic probe cases, pulse, which normally denotes that there's data passing through. As we can't see what's going on inside the chip to see if it's working, for today's purpose we'll be using this LED. Because when the Arduino pulls the pin high, the LED lights up, and when the Arduino pulls the pin low, it turns the LED off. I'm using the basic blink sketch under the examples for Arduino. So I have my advanced logic probe here to demonstrate how we can test this. So if I put the probe end of the logic probe onto the input pin of the LED, we'll see that it says high when the LED is lit and low when it is off, denoted by the red and green LEDs. There's a very simple way of making one of these, and today we'll prototype this on a bit of breadboard. If you don't know what breadboard is, it's a very handy bit of kit to prototype, where you have top and bottom these two lines that are connected this way. So if I put something in here, it goes all the way through to over there, same with this. And then these two sections that are split in two, where everything goes in that direction. Every logic probe should be powered by the circuit that we're testing. So today the Arduino is powering the circuit and has been powering the logic probe. So to start off, we need to take one of these and put it on the breadboard and take the other. So this is the plus 5 volts and ground. Then what we need is 2 LEDs, 2 resistors, and 1 extra lead. The resistors, doesn't matter specifically what range they are of resistance, as long as they are between 330 ohms and 1 kilo ohm, and they are both the same. So what we're doing here is these going straight into the Arduino act like the crocodile clips on the logic probe, supplying power, and then what this lead will do is act as our probe tip. So to start off with, we need to get one of the LEDs. I'm going to use the red one first. There are different lengths of legs. I'm not sure if you can see that fully on the camera, but the short leg, also denoted by a flat edge, is your negative, and the long leg is your positive. This is important to make sure they go in the right way around. So if we take the red LED and stick it into the holes here, so the short leg is in line with the blue wire and the long leg is by itself. We then take the green LED and we do the reverse, making sure that the long leg is in line with the positive and the short leg is not. What we can then do then is take one resistor, making sure it's in line with the other leg of the LED to the middle, and same on the other side, making sure that both resistors go to the same place. As you see, this light lights the circuit up, And there is a reason for this. I'll come to a second, and then we'll put the last one in there, in line with the two resistors, and this makes our probe tip. What we've effectively made here is a potential divider. So if I get this and put it on the input leg, we will see that when it is high, so you see, the red LED is on, and when it is low, the green LED is on. Same as with the logic probe. This is because, as we have here, we have the positive leg on the resistor and the negative leg over here. When this is positive, power is coming down here, through and down there, and when it is negative, it is allowing power to come through here, through this LED and down the probe. And when you're not probing anything, they both light up as power is then going from here, through this and out there. What you can do after this is put this either onto a PCB or enclose it. So if I unplug this board a second, I have got an old felt ballpoint pen, old ballpoint pen case. I have put 2 crocodile clips that are in place of these, and then I have got an old needle which is instead of this wire. So what you do is you would solder both resistors onto the end of this soldering needle, then the other end of the resistors onto the LEDs that are inside here, then the other side of the LEDs where these cables went, you would then solder the crocodile clips. So if I connect the positive to the positive on here, using the Arduino as the power source, you see that both LEDs light up, green and red, like the breadboard did. And if I touch to here, when the pin is high, the red LED lights, you see the light there, and when it is low, the green LED lights. So it's a very inexpensive and simple logic probe to make, and should work between 0 and 9 volts. I've had this up to 9 volts, I have not gone any further. A good way to test to see if this is working is you can put the crocodile clips onto the 9 volt battery and then just touch the tip onto either terminal, and if on the positive you get the red light, on the negative you get the green light, that is it working. So there, that is simply how you do a very simple logic probe, and to make this enclosure took me about 10 minutes to solder it all together and then feed it into this tube, and then I put some glue in either end, and that took 20 minutes to set. So in about half an hour you can have yourself a simple functioning logic probe. So if you liked this video on how to make a super simple logic probe like this and wish to see more, feel free to press the like button and subscribe down below. I'm endeavouring to try and make more simple projects like this, as well as bringing my full project to this channel.
Get vaccine-related facts on Google.
When the battle begins, Ayaka enters her...
All right, good morning. So what we have last time, that video is a video demo on how you're going to be creating your logic probe. That's laboratory 2. Logic probe, by the way, is Actually, that's an improvised one. So, simplified and then improvise. Because if you're gonna really do it, its circuit is quite complicated, no? Pero kadto is simplify ang circuitry, so enable to test logic outputs like zeros or ones from ang gyud, no? So later you'll be introduced to logic gates for this chapter, and you will know what are those logic gates, how they are used inside your computer system, okay? And then how we gonna use logic probe to test the output of your logic gates or logic circuits, okay? And other combinational circuits and sequential circuits. So to start with, let's record this meeting. Let's start with this lecture, and for your laboratory, let's begin with creating the tester of your logic outputs, the logic probe. No? By the way, is my audio clear, guys? Madunggan ra?
Yes, ma'am. Klaro, ma'am.
Usog? Usog ra ang audio? Klaro ra?
Klaro ra kayo, ma'am.
Okay. Okay, so as I said, 1.5 hour. If we could have it 1.5 hour meeting. So let's start by having this lecture notes. Okay. So for a while. Okay, for this, actually it is intended to be given week 3. Okay, but then I gave you this week, somewhat week 2 of our discussion, since we're still waiting for some enrollees to be added in our class, no? So as for now, let's proceed to lesson. Actually, it is the lesson proper, no? It's the start of lesson proper. That's why I called it lesson 1. And we have here the topic logic circuits, no? So under logic circuits, okay, we have this we have the following some subtopics like gates, truth table, Boolean algebra, and then function simplification. So later on, you'll be introduced to functions like similar functions of algebra, but we will deal with different type of algebra that's Boolean, no? Boolean algebra. So when we say Boolean, so it's created by George Boole. So it's a kind of algebra in which there are only two outputs. It's either be zeros or ones, no? So as we all know, our computer system would only understood two numbers, no? Binary numbers, which is zeros and ones. And for electronic circuitry and electrical circuitry, we have some equivalents for zeros and ones, no? So it could be an on and off switch, on for 1, off for 0, or we could have positive negative circuitry. For positive, we have some values like if we have it in voltage 5 volts, and then 0 volt for negative, or we call it ground also for electrical terms, no? So we have differences. They have similarities, but they differ only in the terms, no? We're gonna be using, no? So for this module or this lecture note, you'll be introduced to at the end of this week, you will know the operations of the basic gates. So what are these basic gates, as we call it in our logic circuit, no? And we will be introduced using truth table, no? So what is this table of truth, no? So sa may itong makita sa truth table, is it true or false, no? By the way, other equivalent for on and off switch. So we also called it in the absence or in the presence of signals or electricity. So we have the true or false term, no? So true if there is a signal, off or false if there is none, no? So that is why we came up with this somewhat, no, table, the truth table, no? And then we have also Boolean algebra. So it's created by George Boole, a kind of algebra in which katong nabitaw tay addition sa binary nga 1 plus 1 instead nga 2. Kung sa may answer adto, answer is 0, carry 1. So that's one example of an output of a Boolean algebra. And then another thing is, after knowing these concepts, operations of the basic gates and the use of truth table, and we'll be introduced to this what we call Boolean algebra, we will be combining logic gates, no? So why we combine? To produce a larger circuit. So we call it logic circuits. And somehow, we're gonna be describing how these logic circuits can be analyzed using Boolean algebra. So later on in the discussion or later in the topic, you'll be given some symbolic or symbols of logic gates, and then that symbols is represented by a truth table, and then after which, no, you'll be given an equation in which you're gonna be interpreting it, no. Upon interpreting the equation, Boolean equation, you'll be drawing some logical diagrams out of that, no, using logic gate symbols. So actually, may elaborate na nako later, no. So as we go along, no. So as for this topic, it presents the logic gate, the most basic logic circuit. So again, unsa si logic gate? It's the most basic logic circuits, no. And it will show the usage of Boolean algebra later, and then describe its operation, combine logic gates, and produce logic circuits later, and examine those logic circuit using Boolean algebra. Actually, murag checking nimo, sakto ba ko sa akong gigama nga diagram, no? Through Boolean algebra, Boolean equation, function, nagputay function, kung natay function sa algebra na asad sa Boolean algebra. So anyways, I'll be sending also some supplementary videos, I mean, no, to support the more learnings about the concept. So I know for some of us it's an alien for us, no, but some, I think you have a background already of signals in your electronics, fundamentals of electronics. How about in your shop too? The tools and equipment, niabot na ba mo na may idea about logic circuits, mga AND or NOT gate or principle, no, of the NOT, kung imong inat na may idea about complementation. Kisa ka ninyuhang shop 2, shop 1, Sir Bobby, ano, katong shop 2 ninyo, anybody could kuan kung naa na ba'y gamayng discussion about logic circuits, circuitry, na ba? Or first time yun? Anybody could answer?
No, ma'am.
Okay, yes, Giselle, up to what level ang natun-an na sa logic circuits?
Kaning ingani ma'am nga gate-gate niya mag-combine. Kaso ning pandemic.
Niabot na mo na. So you are solving already Boolean functions?
Oh, nag-solve.
And then you simplify also?
Wa pa may niabot sa mag-simplify, ma'am.
Proving lang sa may kuan, proving of functions lang, nga na. Okay, sige. So it's exciting to note that some of you have already a background of how logic functions are being written, or how you represent logic function using logical diagrams, no? So right now, so it will be integrated with this main topic for this morning, no? So thank you for that, Giselle. So by the way, is there anyone pa nga musud sa klase, no? We are only 63. I'm expecting 70 people. O 62, 63. Variable ang attendance. Is it same people who are not attending? Is it same people? I'm quite conscious with the attendance, especially major subjects, because no, magamit din ninyo soon class. Though you are not into hardware, but it's a very important concept you will know when you do programming also, these concepts. So actually, tulo ra gyud ka gate ang gusto na kong ipa-instill this morning. Kani ra yung tulo, unsa man ning tulo ka gate. This NOT gate, okay, this one, or we call it inverter gate. Another one is the OR gate. We call it the other gate, other, meaning mura siya pwede ka iyang function is mag-add siya, no, kung mga values, no, other. So kare is multiplier gate, no, si AND gate. So kanira yung tulo out anang 3 maka create na tag more complex logic circuits. So out from that 3 logic gate. So actually kanira i-master kani iyang function, no, kaning tulo ka gate. Yeah, the rest is the complement of the other na, because we know already the NOT gate, which is the complementation, no? And then, and so on, no? So, okay, for a while, I need to connect my charger for a while. Okay, so for the inverter gate or the NOT gate, so I guess some of you are familiar, or almost all of you are familiar with how it functions. As we write here, it's a gate, so it's a gate with 2 signals. So again, it's a gate with 2 signals, and one signal is for the input and the other is for the output. And the very thing to remember here about this gate is the state of the input is always complementary with the output. What does it mean? If you have an input, what it means by complementary is your input, your output, I mean, is always opposite to your input. So the result of your output is always opposite to the what signal is you in, okay, what signal is being inputted, no, to this signal gate. So again, this is the symbol, somewhat triangular in shape, okay, having 2 what pins. We have input pin here, and then represented by an A terminal, and then we have an output pin here represented by an X terminal. So after the triangular symbol, we have circle symbol, okay, at the tip of your triangle, no? So what does it mean? So we call it the complementary symbol, or we call it bubble symbol. So what else? The inverter symbol. It simply means that what you inputted here in your triangle is to be reversed by this circle signal here, circle symbol here, and then it will be complemented. Or if you input an A, there are only 2 input signal, right? It could be an on signal, which is a 1 signal, or an off signal, which is an off signal, no? A 0 signal, which is an off signal. So A could be having a value, it's either be 1 or 0, no? Diba? Kay duha raman ka signal, no? So it's either be 1 nga signal, or on nga signal, or off nga signal iyahang value nga pwede nimong i-input, no? So as we look at this representation right here, so pwede tang magsuwat o mano-mano nga combination. So kung natay voltage o signal input, we term it V in, which is an A equal to 0. So obviously our output would be 1. The opposite of 0 is 1, or the opposite of absence is the presence of signal. Or vice versa, if we have an input 1, our output could be 0. So that's the thing. So if 1 is the input, output is 0. And vice versa, if 0 is the input, output is 1. So bisag matug ka, memorize na nimo si inverter gate or NOT gate. Nakuha? So clear iyahang function. So kung naay input mo so diri ni A, no? So timan ilang nga si inverter gate, it's a 2 signal gate Usa ka input, usa for input pin, usa for output pin. So, okay na ta ani? Di na ko ma-zero. Aware na ta unsa ang inverter gate or NOT gate na ay naglibog. So, and this, by the way, this table, we now call it the truth table. Truth table. Mo ni siya truth table ni or the tables of truth ni NOT gate. And later you'll be introduced to more truth tables. So again, take note of this concept, very important, no? NOT gate is the inverter gate, meaning i-invert niya ang input or the input is always complementary with the output. No, na si NOT gate. And we have a note here, no? So the upcoming gates like OR, the AND, the NOR, the NAND, the XOR, the XNOR. So sila is gate also but unsa man. Pareho siya ni inverter having one output lang. Sorry. Having one output lang. So, na siya one output, pero pareho siya ni inverter gate, pero pila man iyahang input, guys. One or more. So, meaning, di limited to one, di limited to two, more inputs. So, again, more inputs, no? So, daghan siya, pwede siya daghan input, pwede po usaray input. So, ma'am, nga naman nga iyang symbol, duha man lagi na ka-input pin, no? O, pwede nga usara ka-input. Well, you could, actually, pwede mo i-merge ning duha ka input into one. Consider na nimo siya, kita kay erase na mo na siyang B nga input. A, i-connect po ni, gi-jump pa niya o wire diri sa B nga pin. So, meaning si B is A na po gihapon. So, that's what it means by, pwede nimo i-convert nga one input, si two input gate. So, by the way, this gate, we call it, si OR gate, no? So, kinsa man ni si OR gate? So again, nakoy lang term niya, other gate siya. So what does it mean by other gate? So, iyang function is mura siyang mag-add no? Og zeros and ones. Unya, ang very thing to remember here, one lang iyang output, take note, the output is high if any of the input is high. So what does it mean? So, kung naku input combination, di ba, duha man sila, it's either si A is 0 or si A is 1, either si B is 0 o niya si B is 1. So, atong combination, kung A is 0 and B is 0, mao ni, no? 0, 0. Kung naakoy A nga 0 o niya B nga 1, naakoy 0, 1 input. Unya next, kung naakoy 1 nga A, unya 0 nga B, so naakoy 1, 0 nga input. Kung 1, 1 ang A, 1 ang A o B, so we have 1, 1 input. So, sa to yung gingon, kung the output will be high if any of these two input is high, so it simply means it's either kung A or B ang high, mo 1 si output. So, let me check. So, so kani 0 mas lang duha, so 0 ang output. And then, namatay 0, 1, so usa nila 1, so 1 ang output, correct, no? So, kari si A na po ni 1, 0 si B, 1 ang output. So, both are 1, so 1 magani, bisag usaray ni 1, samot na ang duha ni 1. Takto, mao ni si OR gate. So, again, thing to remember, the output is high if any of the input is high. Na substance or gate, ano sa iyang symbol? Mura siya og so duha ka input pin and then mo curve ka diri. Okay, curve, take note ha, curve and then talinis sad ang iyahang tumoy. So medyo curvy, talinis, no? So lahi ra sian later. So, usa ka output, take note ha, one output and then minimum of one input. So, kag A or B. So, actually, pwede panig 3, 4, 5 ka input or usara pod. Pwede i-merge iyang input. Usara, mahog nga ira ang input. Karing usa duplicate ni ira. Kung imong i-connect. Imong i-jump ang duha ka. Imong i-connect i-short nimo ang A o B. So, same, one input na siya, usa na naka-input. Wala na siya inverter gate. No? So, klaro ra si OR. Again, usa ni siya, murag other gate. So, anong ingon ko nga other gate, kay kung 0 o 1, i-add 1 jud ang output. So, ma-0 ra siya kung wala siya i-add. 0 silang duha. No? Kung nai-usa nga na 1, mo 1 jud automatic. So, samot nagduha ang na 1. Nakuha mo rin ni kalahian niya, kay di mo ka moingon og 0 carry 1. So obviously 1 jud gihapon ang output. So it's either of the input is 1. So bisan pag dili ra ni 2 input ha. So mabot tig 8 input ka OR gate. So kung nay usa mo 1 adto, output gyud na is 1. Kung 0 ra ta, mo 0 ra ang output kung walay 1 ang mga inputs. So clear ang OR gate? Question? Dili ko ni-emphasize tungod kay kaning tulo ka gate kay importante. Kung makasabot mo ning tulo ka gate, piyungan na lang ang ubang gate. Sakto? Sakto? Nabay pangutana? OR gate? Uy, pangutana.
And so far, ma'am, pangutangan.
Clear? Okay. So, mo na iyang truth table, no? Kaning naa sa kilid, ang kani siya, mo ni truth table ni OR gate. So, next, another very important gate is AND gate. So, AND, so meaning, kung, by the way, napatay analogy, no? Kung taason gila itong discussion, aware man ta sa mga katong union, intersection, kana bitaw nga mga principle. Have you got it in your MMW nga subject, kaning mga about union, intersection nga topic? So, mura na siya ingani, no? Si OR, si NOT, o si AND. No? So, actually, if you turn out ang mga video tutorial about basics of logic gates, ato tabag so good, and then actually, you'll be introduced also to transistors. Kay, actually, si logic gate, inside logic gates are transistors. No? Aware ba ta na, no? So, unsa na nina si transistor? Transistor is the what? The transformation of resistor. So, mama na third generation of computers. Ito ba? O second generation, I mean. Ang first gen of computers, diba, vacuum tubes and resistors. Then we have the second generation of computers, the transistor. What does it mean? The transformation of resistor. Kaya namin nakitaan ang resistor kay umulik siya, guba at tibok circuit. What if thousands of wires imong i-troubleshoot? So, transistor, ang improvement niya na siya ay base collector emitter, di ba? So, most na gibasihan pag-create of logic gates. So, actually, diha ga-base ang logic gate principle. So, if you really want, so I could send you some videos comparing a transistor and then how it generates to the current modern gate logic gates. And these logic gates are packed into one kung billions of logic gates o thousands of logic gates imong itapo, mao na to isud siya og IC, integrated circuit. So that's the third gen computers. Atong gani abot atong mga microprocessors, no? Gamay na lang gid kaayo ang atong chip, no? So actually there consists of gates inside that, logic gates, no? So that creates our computer system. And then AND. So let's proceed to AND, no? So I could give you some links, video links. So actually there are a lot of this in the internet. How we came up with logic gates, ICs, and microchips. No? So AND gate is a multiplier gate. What does it mean? When you multiply something, so when you multiply 0 to any number, the answer is 0. Kunya sa logic Boolean Algebra kay 0 o 1 na may i-multiply, binary numbers I mean. Kung multiply ka any number, if you multiply it to 1, the answer is the number itself, no? So kung AND gate na, multiplier gate, so the output is high if all the inputs are high. Again, so 1 ra, so I think very opposite siya sa OR, no? The output is 1 if all the inputs are 1. So kanira jud ang timan-an nato nga concept kaning last. So meaning kung naay mga zero input diha kay multiplier gate man siya, meaning kaning input A multiply man nimo ni B. So kung may usa na 0, automatic 0 gyud ang output. Unless tanang input is 1 or high. So I represent, by the way, high and low, we represent input high for 1 signal or on signal, input low for 0 or off signal. So klaro? No? So si AND gate is a 2-input gate, by the way, pwede siya sa 1 input, mura ni OR, and only 1 output. So again, kung na true or false ha, pilay output ni NOT or o AND gate, output pin, pila. Imutubag mo 2 or more, 1 or more. So 1 ra ang output, and then how many inputs? 1 or more. No? So ayaw kawa na ha. So, klaro lang, no? So, AND gate, multiplier gate. So, kung na ay 0 nga input, automatic 0 ang output. 1 na siya, the moment, all the inputs are 1. Then, let's proceed. So, this is the truth table or the table of truth for your AND gate. And then, the symbol, kung si kalahian niya ni OR, kung si OR medyo curvy, iyahang, talinis ang tumoy, kari is, semicircle ang tumoy, and then straight lang ang yahang entrance. So mag-drawing ka, duha ka input. Usually kay mao may naa sa market, duha ka input pin na. Then badlis lang no, straight line, and then so drawing. Dili talinis ang tumoy, semi-circle. Okay? So dili is medyo pointed pa ang tumoy, pointed, no? Medyo pointed compare sa one output. So clear? Question ani? Question? An or not? So the next gates are the combination. So si NOR gate, duha ni siya ka gate. Combination ni OR o not gate. So to represent the inversion, we put a bubble symbol or circle symbol after the OR. Mo ni si NOR. So kung imong tan-awon si NOR gate, so ang nga niya NOR, which means not OR. So dili siya OR kay opposite siya ni OR. So kung ang output ni OR, mo 1 siya kung any of the input is high, si OR, ang output ni NOR opposite. Mo 0 siya kung any of the input is high. Nagets? Nagets ang difference? So, it means kani si OR gate kay OR gate nga not OR gate, meaning tanang output ni OR gate opposite si NOR. Kay naman siya bubble symbol after the NOR gate, after the OR gate. Kung imo gud ning i-elaborate ning OR gate class, NOR gate OR gate ra na siya with what? With a not gate nga gisumpay, no? So, sorry. Kung imo ni siyang elaborate, imo ni siyang i-expand, no? Na not gate diri, na inverter gate. Ay, no? Ilapas. So meaning mo ni si OR gate yun, no? Na siya or mo ni si NOR gate. An OR gate with a not with a not at the output pin, no? So to simplify the symbol, OR gate and then bubble and then output pin. So mo na siya elaborated gate niya, no? So question for NOR gate, again not OR gate siya. So unsay output ni OR gate opposite si NOR gate. Same with NAND gate, no? So actually these two are called universal gate. Later you'll be introduced, mo highlight ko jud ko ani niya, no? Kay actually you could represent all the gate using universal gates. So remember again, take note. Again, you could represent all the gates by using universal. Pwede wala kay NOT gate, pwede wala kay AND gate, pwede wala kay OR gate. Later, kung na kay IC nga na kay universal gate, na kay NOR gate o NAND gate, no? Ang sud ana nga IC, pwede na ka mo maka-work out kung mogamit og NOT na kay NOR, na kay NAND gate, mogamit og AND na kay NAND gate. Kung magamit kag OR, na kay NOR. So, later, no? So, elaborate na ko si universal gate. So, again, so, pwede wala ng mga tong not, and, o or. Yan na lang kay universal. Ang nagitawag na sila universal. Kay it could function as the three basic gate man. No? So, another thing, again, NAND gate is an AND gate. Opposite to an AND gate, I mean. So, mo ni si NAND gate, not AND gate, no? So, kung si AND gate, kung sa ganito, the output is high if all the inputs are high. No? So, bali po si NAND gate. The output is low if all the inputs are high. So, meaning, kung duha ka input is high, 0 ang output. So, opposite siya ni AND gate. So, again, same with NOR. An AND gate siya nga naibubble at the output end. So, kung imo na siyang elaborate ang drawing ni NAND gate, so NAND gate ra pud na, ordinary NAND gate with what? Sorry. Okay, straight ra ka. And then, semicircle, NAND gate man. So, an AND gate, sorry. Semicircle, ha? Dagan akong drawing. So, semicircle with, sorry. Okay. So, basta kay an AND gate na with a inverter at the output, no? So, kamo nila itiwas drawing, practice the drawing, no? Later, you'll be introduced to katong akong giingon nga logisim nga circuit, logic simulator software that would test, it will test logic circuit equations, logic circuits, no? So, later on. No? And then, we have another gate after knowing the universal gates, NOR, and NAND. Okay, for a while, Alright, so sorry for that interruption. Okay, we have here exclusive OR gate. So OR na pod, no? Pero lahi siyang OR exclusive, no? So what does it mean? By the way, clear na ang NAND gate o OR gate. Si NOR gate, I mean, is not OR gate. Si NAND gate is not AND gate. Clear lang, appeal ang truth table. Na question before I proceed to the other last two gates, the exclusive OR and the exclusive NOR. Naabay kalibog ato? Clear lang?
Clear, ma'am.
Okay. So, let's proceed. Okay, we have exclusive OR gate. So, ang pinaka mura po siya OR gate, pero naa siya additional what? Curve after the input, no? So, kung imong tan-awon mura na siya OR gate, pero gitawag siya exclusive OR. So, may nakalahi niya. So, as we describe it, when the inputs has an odd, no, parity, it has a high output. So, what does it mean? Ang imurang tibanan nani if they they have pwede po og ang opposite imong timan-an, duha imong pwede timan-an, no? So, kung 2 input ra ni siya nga XOR, 2 input XOR, so as we describe it here, no, pwede sad siya more than 2 input, no, or 1 or more input. So, if we have here, if same ang input niya, both A and B, kung 2 input na siya, automatically the output is 0. Same here, kung both are 1, the output is 0. So, mo na siya, no? Mo na siya exclusive OR. Pero kung 2 input na unya na ay mulahi, it's either 0 or 1 or 1 or 0. If they have 2 different inputs, the output is 1. So, mo 1 na siya kung different inputs, no? Kung lain-lain sila input mo, 0 siya kung same ang mga input mo. So, mo na itiman-an ni exclusive OR gate. So, nga na lang, no? Dito lang akong description. So, this is the truth table having 2 input or XOR gate. If the input combination are same, the output is 0, no? So, same nga 0, same nga 1, the output is 0. If they have 2 different inputs, so, mo ni output. The output is 1. So, nag-guess ang truth table ni XOR. So, kanalay memorize no? Balik-balik, magamit yun na ninyo nga concept. So, actually, dili ko ito kung o di ni ma-master na to ni logic gates. Kaya mo man ito agyod, no? So, klaro ra? Nakuha sa exclusive OR. Patiman itong output ni exclusive OR kay moro po na itiman-an ninyo ni exclusive NOR. So, what does it mean? Si exclusive NOR is very opposite to XOR, exclusive OR. Ano man, exclusive NOR means exclusive not exclusive OR man si XNOR. So, meaning, kung kari siya is kung same ang input, the output is 0 si XOR, opposite si XNOR. If same input, the output is 1. So, kung different input, no? Instead nga 1, output is 0. And same, parehas lang forma na lay bubble at the output side. So, meaning, inverted iyahang output ni XOR. So, mo na si XNOR. Or inverted XOR si XNOR. So, clear? Clear lang? So, okay na ta sa mga logic gates? Okay ra? Pwede na ko mag-exam. Logic gates. Okay, you may chat in the chat box if na-substance ra. Ay, natog diha. Okay ra ta? Can I proceed?
Yes, ma'am.
Boolean algebra. No? So, well, maybe in some other books, okay, medyo taas ang Boolean algebra, pero kanira kung pick, no? Topic, no? So, maybe in some other books, they're using the variables like x and y. So, we will be using a and b or c, no? For the output, and obviously for the inputs, we will be using a and b for this representation. So, what is this Boolean algebra? In following algebra, di ba naman tayo mga rules like katubit ang commutative property. Kinumdum po mo sa inyong algebra, guys. Dapat tayo algebra sa atong high school. Expected, no? Kay pagkilos naman ta diretso pag college. No? So, si algebra, ang hitabo ni algebra natay katong commutative property, associative property, distributive property, no? Nasad ta diri sa Boolean algebra, nasad ng mga distributive, commutative, associative, no? Ang nakalahi lang gid ni Boolean algebra natay mga i-add nga numero sa atong variable. By the way, an algebra consists of a constant and a variable, di ba? So when we say variable, it's an unknown. Variable means it's a letter symbol representing any value. No? So you are using also that one in your programming languages. No? So kung naatay mga values here, so let's say for example, itong unahon ning actually gamay raman ni, no? Kaning addition formula ni Boolean, kaning multiplication formula ni Boolean. Okay? Mao ni iyang mga groupings. And then naatay De Morgan's law kaning ay complementation. Apil pa ni si double knot, no? Then mo na ni si commutative, no? And then associative, then we have this distributive, no? Kani sila. Kanya, kani is additional function niya, no? So actually upat ra ka groupings, no? Ang angay nako emphasize ani Boolean algebra. So the addition part, if your a variable, let's say pwede sa x variable or any variable will do. As for representation, we're using a. So if a is added, so upat ni ka addition, if a is added by 0, a 1, an a, or a not a, unsa may result niya. So mo ni mga rulings nga angay natong timan-an to simplify a complex Boolean function later, no? Because later we will be solving some of these functions, and then while you're gonna be solving it, kung mag-solve tani, mo come up tag simplified equation, no? So mo na gamit mo gamit ang mga Boolean, actually postulates and laws mani, no? Mura sa algebra nga natin isunod yung mga postulates and laws, no? Excuse me for a while. Okay, so we have here so mo lang ni wala tay mahimo ni kay approved rules naman, mga postulates, no? Tadi kalahian ni postulates o theorems o law, no? Kung theorems, mahimo siyang law or by the way, kung postulate pa, before siya mahimong theorem, dapat ma-proven, no? Okay, so mix of theories and laws and postulates man ni siya, no? So murag matawag manig pero gitawag ni siya Boolean theorems in general, no? So kung a kuno added by a 0, the answer is a. So di alta mulalis kay mao man ni as base sa base ni George Boole, no? Ito ang principle. And then kung a is added by a 1 signal or a 1 value, the answer is 1. And then we have if a and a is added, the answer is only a. And then if a plus the complement of a, the answer is 1. Again, take note of those. Kay si addition, opposite na po diri sa multiplication, no? Na side. So that represents multiplication operator. Okay? Okay? Multiplier operator. Okay, we have here a dot 0 is equal to 0. And then if any a is multiplied by 1, the answer is the a. Or a is multiplied by same variable a, the answer is a. And if a is multiplied by its opposite, the not of a, the answer is 0. So lahi dire kay if a is added by the not of a, the answer is 1. Dire, kung imong i-multiply ang not a of a, the answer is 0. Kunya, so nganong maning a dot 0 is 0 man. So anything multiplied by 0, the answer is 0. Kanisad is anything added by 0 is added by anything, that the answer is anything or a. Sakto, no? And then kanisad a dot 1 meaning anything multiplied by 1, the answer is the anything, no? Or the number itself, the a. Yeah. So, mo ni mga rulings, no? So, the moment we simplify later, na ganitay complicated equation like a plus 1, 1 na dayon atong tubag. Or natay complicated equation like a dot 1, a na dayon atong tubag, no? To simplify that equation. So, nag-gets ra? So, it's a matter of familiarization and memorization, siguro gamay. And then, pagsabot sa kada lines of theorems niya. Kung imo na pong i-internalize, makuha raman sa siya a plus 0. Sago ka kay bawo nga a ang tubag. So anything added by 0, the answer is anything, no? So kanila siguro medyo mag-confuse na gamay kaning a plus 1, answer is 1. It simply means nga signal mo guni. Kung naay signal existing, so naa na gyud na siya. So 1 na gyud automatic. 1 is equivalent to 100% signal. Kunya kung mag-plus ka, kung same signal, the answer is the duplicate of that, no? And then kung opposite imong i-add, so 1, mahog man good nga 1. So kay nga naman na. Kay it's either kung ang A ang value is 1, unya ang B is, so by the way, kaniding mga postulates and theorems natay laboratory ani to prove the claim of these equations. Actually laboratory number 6 na, no? Mga Boolean theorems. I-test ni na to siya. Katagsa kung sakto ba yun, no? Sakto ba yun ni, no? And then we have excuse me, no? This De Morgan's theorem. Okay? So si De Morgan's naa siya'y uy, nawa maning B diri. By the way, class A plus B ni siya, ha? Nawa si B. Complement of A plus B is equal to not A plus dot not B. So again, murag imo ra man ning i-distribute ni si kaning complement means the not, no? Okay, for a while guys, ha. I drink some water. Okay, so we have here A plus B, the not of A plus B is equal to not A dot not B. And the other one is open and close parenthesis A not B complemented is equal to not A plus not B. So meaning, kung A plus B here, kaning A plus B, wala pa siya not, isud sa parenthesis, yung ginat sila, i-complement sila as a whole, mao na niyang result. Not A, na not si A, na not si B, at the same time, na-change ang operator. Sa kaning opposite ni plus, multiply. And vice versa here, kung the A multiplied by B, wala siya not, no, ang A of B, pero close inside parenthesis, niya ginat, automatic ang result, not A, unya ma-change ni multiplication operator to positive plus, so not A plus, not B na. And then we have also other complementation. If A is double complemented, double not, so A not, not A, not A, not A is being notted, that's equal to A kira. Ano naman, makancel maning natin. So, makugra nga, mura man siya ginga ni A, not of A, no? Tahay not of A, na bar si A. Yeah, ibutang ni mo parenthesis, not pa din. So, makancel ni siyang not. So, equal to A, lagi hapon answer. Okay? A, lagi hapon. And then, kani silang mga, no? Commutative property, itong binali bitaw, A plus B, pwede rin sa basahon mo as B plus A. So, naasad ni multiplication, sige na pilang multiplication. Let's say A times B, answer is B times A rasad. So, kani siyang usa, associative, kung ingani ang pagkasuwat A plus, open parenthesis, B plus C, equal rasad na siya to what? So na, A, open parenthesis, A plus B, close parenthesis, plus C. So, more na siya ang parenthesis ay na-outro plus up. Nadunggan pa ko? Are you still with me?
Yes, ma'am.
Yes, ma'am.
Do you still follow? Do you still follow?
Yes, ma'am.
And then another thing is parts associativity is we have A, kung kani plus ang atong gigamit, kani sa is multiplication. So, kung ang gisod sa open close parenthesis is the B dot C, then it's just equal to open close parenthesis A dot B times C. Actually na siya hidden operator diri, multiplication operator kaning dot, kani A dot B times open close parenthesis C, and then same with A dot B dot C. Ang parenthesis line outro class. So kani diri next is the distributive law, no? Uy, nawa ang multiplication lagi. Nawa sa multiplication lagi. So kani class napa ni pakapin nga A dot B ha. Nawa ang A dot B. Kung AB is just equal to BA. Ngana, no? Pwede siya na-upin. Pagkapipis, no? Pagbutang sa material, no? Nakuwangan siya. And then we have, asan ako? Diri na sa distributive law. A, so nani siya, dot operator, diha, hidden operator, automatic na multiply, no? Kung A in the open and close parentheses, no? A times B plus C. So, kung imo ni i-distribute, is EB plus AC. So, nag-gets ra, distributive law, no? So, nasa di siya nawa ang kuan. Nawa ang opposite ani kung times kung nakita diha na po di plus, no? A plus nya open and close BC nga na multiply diri BC AC, and then is equal to sa man distribute nini mo AB dot AC dot, no? So ang operator ma-change. So same ra siya ning kani pero addition ang A plus ni open and close parenthesis B dot C instead ng plus. And then ang result ana is kung plus ni, so meaning A plus B dot kani mo ma-dot A plus C. So na-gets, no? Kuwangan ni usa ka line, no? For addition A plus B dot C. No? Sige lang, mag-send ko ang modified katong ibutang na ko ang kuwang, no? Apil ning usa kuwangan sa ni ang multiply mo inawa ani, no? Sa commutative. And then this one, so additional kani mo powerful sa kaayo nga simplification rule. Kung napuno kay A, gitawag ni siya absorptive absorption, law of absorption, no? Kung napuno kay A plus not AB, automatic mahog nga equal na siya sa A plus B. So murag gi-absorb ni B ang not ni A plus not AB is equal to A plus B. Same thing kung nakay not A dire plus AB, i-absorb ni B ang iyang A. Mahimo ng not A plus B. So sa tawagan na absorption theorem. So na substance, so actually ang iyong timan-an is upat ra ka major, unya the rest kay common man ni siya, no? Katong associative, commutative ug distributive, familiar naman tadaan. Kanilang siguro murag stiro na to. Ang De Morgans, dili ra sa De Morgans kay complementation of all raman. The variable imo i-complement as well as the operator. So kung nag-plus ka dire, yung complement mo, ang mahitabuan na is times dire ang operator unya manegate nimo or ma-complement na ang mga variable. And vice versa. Kung multiply dire, ma-plus dire. Unya, take note, i-negative, itangan nimo bar ang imong variable. Nagets ra? Question please. May question? Isa naglibog. Pamuta na. Very good. We are still intact. 64. Nagi mga absinos ba? Isa mo gining absinos. Question B? Nay naglibog ba? Nay naglibog? Wala na? Wala question? Uy, pangutan na. Mawa mo question? Mo PM na lang? Karoon na question di. So, in our separate sheet, okay, you may screenshot this one to start solving in your seats, no? We could submit this one next meeting. This practice exercise. No? So you may answer in separate sheet. So I'll be assigning this one to your Google Classroom so that you could turn in. Okay. So I'll be sending also this in your Google Classroom, this material. And then, so far, mo end ko aning Boolean function simplification, no? Para manilay-nilay sa ninyo ang theorem, memorize ninyo gamay, as well as the basic gates, katong mga logic gates, no? Kay naapay upcoming ani, no? So, ang next mga topic is katong universal gate, then ato ta sa K-mapping, no? And then, katong using max terms and min terms. So, after ana is mag-create na tag mga combination circuits, no? Combinational circuits. So far sa inyong shop to, ani ra mo taman, Giselle? Or naka-simplify gid mo?
Ana to, ma'am. Pero, nakalimot na may.
So, na-refresh, if ever. Na-refresh mo, ani.
Yes, ma'am.
Question be? Walay question? Kanin, saan na ni pag-solve? Be. High-end, ani. So, gamitan na ninyong mga principle, no? Kani kay medyo complicated man ang equation. Using this theorem, i-simplify siya, no? You try this one in your home, no? Try to solve using separate sheet. Yeah, I'll assign this one to your Google Classroom. So, na-screenshot na, kani? Screenshot na ni, kaning atong activity, gamay nga activity. So, actually, you could solve a lot. Kung ganahan, di mo kontento sa akong ihatag nga exercise, you could still solve another equations, no? Mas complicated, ani, no? Para ma-master din ninyo ang simplification.
Question, ma'am.
Like, yes, question.
Ang ka na bitawng sa ika-third sa second column sa Boolean Algebra. Ika-third from the last.
Third from the last. Kani?
Oh, kana.
Kanang question.
Kuan na A plus B plus C or A times B plus C.
AB.
Kana, anong part?
Sakto. AB plus AC.
Ang kanibang dugang na sa
ang idugang ani is A plus kanina sa ubos. A plus times B dot C. Yang answer ana, ang sabi answer ana? A plus B na open and close parenthesis. Mahog nga ang imuhang mid operator, imong ilisan og times dot A plus C na. Nagets? Open and close. Nagets? Kuwangan siya, kuwangan. Kaning, sakto ning, sana? Sakto na ni kani. Sakto ni. Ang opposite niya mo, iwan ho na suwan. Kaning A plus.
Sige. Okay, ma'am. Thank you.
Question. Ilang send lang siguro kung modified aning kaning material murag na delete ning kana nga part ana, no? Uha ra. Sige, so may question, Sel?
Okay na, ma'am. Mara to.
Naglibog ra. kanina pa ni pakapining kuan ha kaning si associative bitaw plus may na pa ni multiplication nga side. Kung A plus B is equal to B plus A, naani siya AB is equal to BA. Wala na suwat na po. AB, ang multiplication niya ba? AB suwat is equal to B dot A. B dot or BA. Ano siya? Duha man ni sila. Kung na kay A plus B is equal to B plus A, na po ni A dot B is equal to B dot A. Ano kuwang rana. Sige. Before ko mo end, ako ipakita to balik tong logic probe na demo video kay for your laboratory manggod bisan og so at least guys, can we agree that each of us could provide ourselves a small breadboard and then LEDs, resistors, and then katong gipakita bitaw nga material ganina, mga wires, no? So sa man nga klase nga wire, naatay later ha. Katong solid wire man to actually kay kanang makatusok bitaw din sa breadboard nga pin, no? By the way, kinsa nay naka-encounter og breadboard, nakahawid na breadboard physically. Napay wala. Napay wala kahawid og breadboard.
Nakahawid ang isa na. Wow.
Nakahawid mo unsa nga?
Nakahawid
nyo.
Yes, ma'am.
Nakahawid na tanan, so abi ko wa pa, no? And then mga LED. IC. Solid wires. So, actually, different types of wires. Na solid wires, na ay katong, ano na? Kalimut ko, humok na wire ba? Itong dili solid, ang ihang sod. Kanya, katong mga alligator clips. Familiar naman tanong sa katong ipakita bito sa video, ganina. Para asa si logic probe, just a tester lang, kung sakto ba ta sa atong output. If the intended output is 1 or 0, matest lang nato kung 1 o 0 ba gyud using that logic probe. No? So, mo to nga, kung sa allow me to play it again, ganina, medyo kasi wala ayo maklaro. Unya, allow me to play also the demonstration on, basic demonstration on how you gonna use your Logisim to simulate logic circuits later. Okay, magsugod naman dito sa mga logic circuits. Laboratory 3 actually is logic gates, basic gates. And then laboratory 4 will be universal gate. And then laboratory 5 will be katong mogamit siya og Boolean equation nga i-simplify onya x or x nor di ay onya ang laboratory 6 is kato ng mga theorems mo iyahang i-test yan so on na no so kato mga combinational circuits no so mo ligid to daghan gyud dapat kayo laboratory mo di gid mahumantanan kung itong i-implement tanan so the span of time onya kanang materials no. So well, naaman tayo mga gamit ka ha, makatest-test na sa atong bayon niya. Katong logic probe, pwede to ninyo ibutang og case. By the way, you could use katong improvise bitaw nga logic probe, pwede nga pen, katong ball pen, kato yung ipakita niya. Dagom sa pwede ka nang og nay sirens, mas maayo katong mga injection gani. Ang yung mga injection no, may mga hilig og kuan no. May mga sirens sa ilang bahay no. Kadto ra isod ninyo ang wirings o circuitry niya. Anyway, duha ra man ka LED o resistor ang inyong ibutang og printed circuit board. Kay ba na sad ta mo gamit og printed circuit board? Sa inyong electronics na amoy gagama mo mga IC, PCB, PCB designing ta. Familiar? Hello. Nag-PCB designing ba ta sa to electronics?
Yes.
Nag-itching ta, no? Nag-itching. Kay bao na ta mo, kay bao ta, no? Mo gamit sa PCB. So, or, kung di mo ganahan, pwede lang isolda ninyo dito ang mga connectivity nga wala na siya PCB. Pero mas safe kung ibutang siya PCB, guys. Gamay ra, no? Mura ning sa video na to. Now na to ha, balik. Play na to ang video. For a while, give me a second to stop, share. Share. For a while.
We know about hair loss and balding. Scientists made a shocking discovery.
In today's video, we'll be looking at how to make a simple logic probe. If you already know what a logic probe is, feel free to skip to this point in the video. If you don't, feel free to carry on watching. So a logic probe is normally used to test integrated circuits. The pins on the circuit are high, which means there's voltage, low, which means there's no voltage, and in some logic probe cases, pulse, which normally dictates that there's data passing through. As we can't see what's going on to the chip to see if it's working, for today's purpose we'll be using this LED. Because when the Arduino pulls the pin high, the LED lights up, and when the Arduino pulls the pin low, it turns the LED off. I'm using the basic blink sketch under the examples for Arduino. So I have my advanced logic probe here to demonstrate.
Okay, you may not use Arduino, guys. If you have any power supply at home, or battery lang, 5 volts na. Na battery, pwede ra sad og dili Arduino ang gamiton niyo for positive negative supply ninyo. Kani ang gigamit sa video is Arduino, no? So, or if you have some kits, much better. Kung naagid may Arduino Uno ni ang gigamit na supply. So, pwede ra pod battery or anything pwede makasupply o LEDs. Okay, light emitting diodes, no? Let's continue.
How we can test this. So if I put the probe end of the logic probe onto the input pin of the LED, we'll see that it says high when the LED is lit and low when it is off, denoted by the red and green LEDs.
Okay, so ang iyang gigamit nga logic probe ani is katong kanig yung nipalit siya dili improvise. So high-tech nga logic probe, no? Kaning later yung i-demo how you improvise based on this kaning nga device yun nga logic probe na pinalit sa market, no?
There's a very simple way of making one of these, and today we'll prototype this on a bit of breadboard. If you don't know what breadboard is, it's a very handy bit of kit to prototype where you have top and bottom these two lines that are connected this way. So if I put something in here, it goes all the way through to over there, same with this. And then these two sections that are split in two where everything goes in that direction. Every logic probe should be powered by the circuit that they're testing. So today the Arduino is powering the circuit and has been powering the logic probe. So to start off, we need to take one of these, put it on the breadboard and take the other. So this is the plus 5 volts and ground. Then what we need is 2 LEDs, 2 resistors, and 1 extra lead. The resistors doesn't matter specifically what voltage, what range they are of resistance, as long as they are between 330 ohms and 1 kilo ohm, and they are both the same. So what we are doing here is these going straight into the Arduino act like the crocodile clips on the logic probe supplying power, and then what this lead will do is act as our probe tip. So to start off with, we need to get one of the LEDs. I'm going to use the red one first. there are different lengths of legs. I'm not sure if you can see that fully on the camera, but the short leg, also denoted by a flat edge, is your negative, and the long leg is your positive. This is important to make sure they go in the right way around. So if we take the red LED and stick it into, so the short leg is in line with the blue wire and the long leg is by itself. We then take the green LED and we do the reverse, making sure that the long leg is in line with the positive and the short leg is not.
Okay, take note of the legs of the LED. If we have the ground for the negative for the ground connection, we use the red LED. So ang iyahang short leg connected sa ground, unya ang iyahang longer leg asa man nabutang. So iyang longer leg is sooner i-connect siya sa resistor. And same thing, opposite si green LED, ang iyahang long leg nabutang sa positive, no? Unya ang iyahang opposite leg katong gamay. By the way, ang negative leg ni LED is katong gamay ang tumoy, di ba? So and then ang output annihilator, kung naay signal mo siga si red, kung wala mo siga si green. So mo na siya yung output. So please take note kung medyo dili klaro ang video. Okay, let's proceed.
What we can then do then is take leg is your positive. This is important to make sure they go in the right way around. So if we take the red LED and stick it into the holes here, so the short leg is in line with the blue wire and the long leg is by itself. We then take the green LED and we do the reverse, making sure that the long leg is in line with the positive and the short leg is not. What we can then do then is take one resistor, making sure it's in line with the other leg of the LED to the middle, and same on the other side, making sure that both resistors go to the same place. As you see, this light lights the circuit up, and there is a reason for this. I'll come to a second, and then we'll put the last one in there in line with the two resistors, and this makes our probe tip. What we've effectively made here is a potential divider. So if I get this and put it on the input leg, we will see that when it is high, so you see, the red LED is on, and when it is low, the green LED is on. Same as with the logic probe. This is because, as we have here, we have the positive leg on the resistor and the negative leg over here. When this is positive, power is coming down here, through and down there, and when it is negative, it is allowing power to come through here, through the LED and down the probe. And when you're not probing anything, they both light up as power is then going from here, through this and out there. What you can do after this is put this either onto a PCB or enclose it. So if I unplug this board a second, I have got an old felt ballpoint pen, old ballpoint pen case. I have put 2 crocodile clips that are in place of these, and then I have got a old needle which is instead of this wire. So what you do is you would solder both resistors onto the end of this sewing needle. Then the other end of the resistors onto the LEDs that are inside here. Then the other side of the LEDs where these cables went, you would then solder the crocodile clips. So if I connect the positive to the positive from here, using the Arduino as the power source, you see that both LEDs light up, green and red like the breadboard did. And if I touch onto here, when the pin is high, the red LED lights, you see the light there, and when it is low, the green LED lights. So it's a very inexpensive and simple logic probe to make, and should work between 0 and 9 volts. I've had this up to 9 volts, I have not gone any further. A good way to test to see if this is working is you can put the crocodile clips onto the 9-volt battery and then just touch the tip onto either terminal, and if on the positive you get the red light, on the negative you get the green light, that is it working. So there, that is simply how you do a very simple logic probe, and to make this enclosure took me about 10 minutes to solder it all together and then feed it into this tube, and then I put some glue in either end, and that took 20 minutes to set. So in about half an hour you can have yourself a simple functioning logic probe. So if you liked this video on how to make a super simple logic probe like this and wish to see more, feel free to press the like button and subscribe down below. I'm endeavouring to try and make more simple projects like this, as well as bringing my full project to this channel. In today's video,
Okay, alright. So, kanang naabay question adto. Klaro ra ang iyang unsaon paggama, no, pag-assemble. Question ba labong wala pa ta ka-off sa video. Ako ibalik adto nga portion. Anyway, I'll be sending this video link. It's available in YouTube. In our GC, I'll be sending it also in our Google Classroom later. And I'll be posting this material also. And for the output of this one, on top nga fill-upan ninyo to ako experiment form, you will also send me a short video, bisag mga 2 to 4 minute video nga nag-assemble gyud mo in your own, individually. So, mag-upload mo ani, gamay nga video nga i-prepare yung mga materials, unya nakasoda mo insakto nga mao sa ato ang connections. Anyway, I'll be sending also the circuitry of this one. By the way, kato akong material nga i-send di ay is opposite sa kaninga video. Kung kaninga video mo lights on o positive is ang red, kadto is ang green ang mo light, no? So, pwede both inyong suwayan. Anya, ang resistor day nga gamiton is either sa material akong gibutang is 1 kilo ohms. Pero pwede ra sa do basta kay makasiga siya LED, dili mo buto inyong LED, dili mo break out, no? So 1/4 watt na lang ang gamita para mas gamay kay 1/2 di maigo sa kuan ballpen case, no? Kung ballpen yung gamiton, pwede ra sa sirens, no? Para mulbo tong LED, di nang mabubuho sa sirens, no? Ano bitong injection yung ana gamita, nya na po siya dagom. So, gamit siya kayo, samot na mo balik na tawag physical, kadto magyuy akong gamiton for checking, mo mag-check tag mga output, kadto rang logic probe. So, dapat kamutan na naagid mo tagsay tester. So, agreeable ra ba tong activity? Naabay objection, clarification, comment? I'm happy nga niabot tag 68 unya ni balik na pug 66. Question be. Willing ba ta mo create adto individually?
Hello.
Yes, ma'am.
Si Jusel lay mo tingog. May lay mo tingog. Okay, so more po tag ka ng mag-upload tag video nga more self-introductory ba nga. Okay, so magama na ko. So ang essential na nako is makita lang yun nako kung proper ang connectivity niya paggama, and then kung mahimo mag-testing yun mo mura to yung gibuhat nga demo, no? So siguro ano lang, maximum is 5-minute video siguro. Ana nang all set na tanan, ana nang magsugod og video na nang materials niya. Kato na lang pagbutang sa breadboard niya. Pwede ra, okay na po itong magbutang sa breadboard siguro. Bahala din na, ipakita na lang ninyo ang ikat na ninyo niya. Kato ng final output ninyo. Yan na lang mo i-test. Yan na lang siguro. Kita lang kung sana. So later man sa atong laboratory, groupings man no, pero kung unom ang members per group, by the way, na-groupings na ta sa laboratory. Ito akong gi-assign nga groupings. As mayor, na-groupings na mo?
Wala pa, ma'am.
Pila ko members per group ganito akong giingon? 6 ba to?
6, ma'am.
Yes, ma'am. 6, ma'am.
Okay, kung 6, next laboratory kay grouping naman, kating laboratory 3, nga nilang sigurang style, kung unong ka members, so for lab 3, una nga member sa lang ang mo demo, siya mo submit og video in representation with the group output, pero na yun siya gamit, no? Kung mahimo, no? So kung dili man siya, or so siya mo initiate, no? Basta kay tanang pangalan ninyo, at tanan mo, makitaan mo na ho nga nakagama gyud mo usa ka output sa logic, no? So kung mong unong puli-puli mo, in representation sa group 1, ako mo ay mo submit og video, group 2 ako na sad, so para dili ra usa ang mabugatan, no? So sharing of idea, sharing of output, pero kamong tanan makita gyud nako nga nakasubmit gyud mo individually pod, no? Kay kung actual, kung physical pa ni, mag-groupings mo, tapo mo sa, kung unong mo, tapo mo sa kalingkuranan, sa kalamisa, unya, si Usaragay magpa-check, siya ang magpa-check, siya akong pangutanon, in representation sa whole group. Kay para tanan, na ay, so, murag ko ano ba, salitan, no? So, next na po ng activity, siya na po yung magpa-check. So, at least siya makamao mismo mo, check man lang og output, no? Using the logic probe, no? Siya man lang mismo, kaya ako man ang i-anwar, makahibaw siya, asay gi-anwar na ko, no? So, karon kaya di mo na ma-realize, so at least ikaw mismo, i-assemble yourselves, organize yourselves, maka-convincing nga ikaw gyud nakamao gyud kasi imong gibuhat, unya at the same time, ang whole group na represent imong maayo. So, ingana atong output ha. So, okay ra ba? Ready na ta? Murag mag-video gyud tagsa-tagsa. Pero anyway, nga ni ha, ang concern ma'am, what if wala may gamit ma'am or kuan. So you could demo using circuit maker or Logisim, pero ikaw ang mag-discuss nga ingani ang kuway, ingani imong connection, unya ingani ang pag-test sa output, blah 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 blah. So kung di gyud ma-realize nga sa breadboard mo mag-test kay unavailability of materials kintahay, no? So, consider ko as long as klaro ang imuhang presentation sa output, unya namaog yun ang pag-execute sa laboratory activity. Bahala og simulator ay imong gamit. So, agreeable ko nga simulator as well, basta kay klaro ang maklaro ang discussion. Dili ra documentation ang klaro. Mapasabot ninyo na ho o mapakita nga nakasabot yun ang whole group or kamo individually. So, clear ba? Kaya ba sinay mo react nga, ma'am, di naman ikaadtog tagbilaran, etc. Pero lami yun o breadboard. Mas bonus ninyo, bonus sad nako. Merit additional points nako kung nag-breadboard yun, no? Nya napag yung simulator, gawan kayo, no? Nag-send pa og circuit nga mao gyud niya mong final output, no? Plus na pa demo video, no? So accepted both ha. Pwede breadboard mag-demo sa pag-testing using logic probe kada grupo nga output. Usaray mo submit, no? Or ari ko sa simulator ganito
sa simulator nya na mao man sad ang pagka-demo, no? Either kung implement sa breadboard or dili, mao ra man gihapon, no? Okay ra? Substance. So kung okay ta aning sa logic probe di ay pwede ka magamit og logic circuit maker. Naka-download na mong circuit maker. Kung wala, bisa katong logic sim kay mao gitoy simulator sa logic circuits. Ang si circuit maker, mga circuit tree like kani kita magama kay nga ni logic probe, pwede ra to nimo i-simulate dito, no? So si nakoy demo video, gamay lang background, pwede ka mo na mo enhance o mo view og more for demo sa Logisim, no? So last na lang yun before mo end ko ani nga session kay laboratory meeting, di na ko mo meet ninyo, you start creating your logic probe. So for this week karon na ta mag-meet, no? So for the next meeting, tama next week is laboratory 2 inyuhang gamon unya quiz ta next week sa lesson 1, no? So forward sa ninako sa mga moapas. So clear? Akong i-show ang demo video sa Logisim. Okay pa ba ta? Naa pa ta diha? Okay pa?
Napa, ma'am.
Okay, ako lang ito, bahalag ka mo yung review. So anyway, isan man ako ng link, no? Kay at least aware lang mo nga mo din purpose ani nga video. So for a while,
Okay, in this video I am going to walk you through an example of a circuit. We will take a Boolean expression that we derived from the truth table and create a circuit on Logisim and simulate it to verify that the circuit that we came up with actually works as intended. Okay, so let's start out with the truth table. So here's the truth table. A, B, and C are the inputs, and D is the output. D is a 1 under these three conditions. Okay? Under these three conditions. So from there, here we have a Boolean expression. D is 1 if A is 0, and if either B is 1 or C is 1. So the Boolean expression is D is equal to not A ANDed with B or C. Okay, so let's draw this circuit on Logisim. Okay, so there we have three inputs. So let's bring in, this is the main window of Logisim. This is the hand represents a simulation cursor. I'll talk a little more about that in a second when we're ready to simulate the software, so simulate our circuit. The arrow is a regular arrow. A here is a text box. This is an input. This is an output, and this is a NOT gate, an AND gate, and a OR gate. Okay, so for this particular circuit, we have A, B, and C, three inputs. So let's bring those guys in first. So let's place our inputs A, input B, and input C. Now this part of the screen has more libraries, more gates that we are not going to use right away. These are the properties of these inputs. Okay, so I'll talk a little more about the property in just a second, but these are the three inputs. Now let's label them. So to label them, I click on this button, bring it where I want, and I start typing B, C. Okay, so I have all of them. I also need one output. So let me grab an output and place him here. Okay. Now if I look at the property of the output, it says label to east. So that means this output button is facing the east direction. Okay. If I click on this, the label says west. So that means this is to the facing right or west. Okay. Now let's look at the equation real quick. Equation is not A, so that means we need a NOT gate. We have an AND, so we need a AND gate, 2-input AND gate, and a 2-input OR gate. So let's bring those guys in. So let's create NOT A first. So we have a NOT gate. Okay, to wire, simply take your cursor here and left click and pull it to the end. Okay, if you make a mistake, just highlight the wire and hit the delete key. Okay, remember again. Okay, when I wired this time, notice this. Right now this pin is red. Now when I start wiring, so to wire again, take your cursor to the place from where you want to start, left click and drag, release. Okay, so that's a complete wire. Notice how this turned green from red? So that indicates that this has been wired to the input. Okay, so we have NOT A here. Okay, we have NOT A there. Now we need B or C. So for that, let's bring in an OR gate. So here's the OR gate. Now this OR gate has 1, 2, 3, 4, 5 inputs. We actually really needed a 2-input OR gate. So highlight this. You can go and change the property of the OR gate to make it 2-input. 1, 2. Okay. All right. So we've taken care of NOT A. Okay, we've taken care of this part, and then we've taken care of this part. What we need now is to do an AND between this guy and this. Okay, so we need an AND gate, and we also need a 2-input AND gate. Now, okay, we need a 2-input AND gate. All right, my output is right on the way, so let me move it. To move it, go back to the cursor, highlight that guy, and just drag it around. Okay, now let me wire this guy. Okay. E indicates an error. Okay, so right now the AND gate is not wired, and it has 5 inputs. We only need 2-input gate, so let's change that. Let's drag this a little. Let's drag these guys a little more. Okay, so let's wire them. Okay, so they are now wired. Okay, now it's time to simulate. To simulate this circuit, we use the hand tool. Okay, during this mode now when my cursor changes to a hand, I can click on an input, and it will toggle between a 0 and 1. Okay, so now let's look at our truth table. Our output should be a 0 when it's 0, 0, 0. Let's verify that that's the case. 0, 0, 0 is 0. When we have 0, 0, 1, our output should go to a 1. 0, 0, 1. So that's 1. So here we go. This is right. This is right. Let's go switch 0, 1, 0 is a 1. 0, 1, 0 is also a 1. How about 0, 1, 1? 0, 1, 1 is a 1. So that is also correct. 1, 0, 0, and everything else should be a 0, right? So 1, 0, 0 is a 0. 1, 0, 1 is a 0. 1, 1, 0 is a 0. And 1, 1, 1 is also a 0. So I verified all these guys also to be correct. Okay, so that's what the simulation software does. It allows you to take a equation that you derive from a truth table, build it, test it before you actually physically build a circuit on a breadboard. Okay? Now this example seems trivial because it's very small. This simulation software will be a lot more helpful when you have a very big design. Okay, so refer back to this video, and if you have more questions, feel.
Okay, so nasabtan lang ang video. This is the environment of your Logisim. You could install this one. You could download it for free. You may Google it, no? And then pili lang ka unsang version, pwede katong latest, katong kinadaghanan ang ni-download, no? And by the way, mo upload sa ka og Java environment before ka makagamit sa Logisim nga environment. So anyway, i-direct ka niya sa site sa Java, then i-install sa tunay mong Java, gaan naman siya class, and then before ka maka-open sa imuhang Logisim. So try lang, kisa may naka-install na sa Logisim na ana. Actually, mao ni iyahang icon for a while, mura siya og OR gate based sa demo, no? Gadagan siya sa Java, diba, nga logo, Java nga environment, pero ang Logisim mismo is, ang iyang icon is OR gate ang ang yung shortcut icon, I mean. Okay. And then another video nga mas mo-simplify pigud ani atong gipakita karon, yang i-elaborate ang environment tanan, menu bar, kaning sa side, kaning pinaka-environment niya, editor, no? So sa akong i-share nga video. Anyway, itanaw lang ninyo nigbalik, no? So later.
Hello, welcome to all. I'm back again. I'm Vaibhav, and today we are going to discuss about one of the best tool available to design the circuits, electronical circuits, and to simulate the working of electrical circuits before implementing it practically. So we have a tool called Logisim. It is basically built using Java. So to install this, to install this tool, we need to install the JDK, that is Java Development Kit, and then we can download it easily by using the Logisim website. It is freely available. So let us start with the basics of it. So basically we have a window, a framework what we are using for this. And this we have the menu bar, we have the toolbar. Basically it is divided into four parts, you can say. We have the menu bar, and we have the toolbar, we have the canvas. This area is called as a canvas. Then where we have the attributes for the elements what we are going to use. So let us understand how to start using this. So whenever we require to understand the working of any electrical components, we can use integrated circuits. So in practical way to implement that, we use breadboards and ICs, integrated circuits, and wires to connect that. And based on the inputs what we provide, we can understand what is happening, what output we are receiving. So this is basically used to design the circuit before practically implementing it. So let us start with the simple components of it. So to have this, we can, suppose I want to implement the AND gate, these are the basic logical gates, and how to finalize, how to analyze the truth table of this. So let us start using this. So in the side pane we have the AND gate. These are the gates. So let us take this gate. Either you can click on this and just drag it. You can add the gate. Okay. Or otherwise, one more option. Suppose say I want to take a OR gate. So I'll double click here and I'll just place it here in the canvas. So this area we call it as a canvas. So now let us understand basically whenever we add any element in the canvas, so we can change the attributes of it. So basically a gate will be having a facing. So if you consider this, the gate is facing at the east. So we can change the facing of these gates. I mean, in which face we can change this. So like this we can change the attribute. Next, coming to the, for our concern, basically we'll understand the size, how we can change the size of it. We want if a smaller one or a larger one, so that we can change the size of the logic gate. Next, basically it comes with, by default it will be having 5 inputs, so we can change it to 2 inputs. Basically we are going to take 2 variables and 1 output, so we'll be having 4 combinations to test this. So next, we also can change the label font, which font size we want, what is the font size required. So all this we can change it. So let us understand what is required to do this. So I have included a gate here, and if you observe this, there are some 2 blue dots. So these dots indicate that these are the pins to which I need to connect the wires. So to connect the input pins, we need to have the inputs pins to be connected to this. So I can add the inputs pins here. So in this, this square indicates for the input pins. Okay, so I need to have 2 pins. So I will connect this with the wire. Next, I will take one more wire, one more pin I will take, and I can connect it this to, so you can, if you want, just you can drag it a little bit and then you can connect it to this. So this is how we can connect the input pins and the wires. So now I required is the important thing element is the output. So I will add one more wire to this, and then I will add output to this. So to add the output, you have to select this add pin, which is in the circular color. So just take it and add it to this. So what is this blue indicates? This blue indicates that the value of this output is unknown. We have not yet executed this, so it shows a blue mark with a X symbol. So this indicates that the value is unknown to us for time being. So then connect to this, and then we are going to test the circuit. So we need to understand the truth table for this. So basically the truth table for the AND gate will be true only when all the inputs are true. That means if we take true as 1 and false as 0, so when both the inputs are 1, the output will be 1. In other combinations it will be 0 or it will be false. So to implement this, we have we can execute this by using this, taking this hand symbol, or you can say a poke. So that means by poking we can change the values of these inputs. So I can take this tool. So after clicking on this, I can change the values. So by default, whenever we have the after designing this, we'll be having the combinations at 0 0. So already it is showing the output for the 0 0 values of input. So let us change the combination. So 0 0 is already done. So I will take 0 1 next combination. It is again 0. So now I will take the next combination as 1 0. So and then this is 1 0, and then I will take the final combination as 1 1. So by doing this, we are analyzing the circuit. We are understanding that whatever the truth table says for the AND gate, we are implementing it on the circuit. So this is how the designing of gates is done in the Logisim. And we can have the we can add the attributes to this. We can add the variable names to this. So to add the variable names, we can take this text box, but whenever we are adding the text box, please try to add the text box on the particular pin only. Okay, just take this and add it on the pin, input pins. So I will write it as A, and this I will write it as B. So similarly, I will write it on C. The advantage of adding the label on this pin particularly is, suppose I want to shift this circuit. I want to move this circuit. So if I move the circuit by selecting everything, this labels will automatically move with the pins. If suppose I label it somewhere here, like say D, and if I select this, so I'm sorry for that. So if I select like this, and if I move this, so with my circuit, entire variables are also, all the variables are also moved with the pins. So this is the advantage of giving the variable names at the pins itself. So let us go to the option that is project, and then we'll be going to the option that is analyze circuit. So when we go for the analyze circuit, it will show the table. So what we are having, so it shows the inputs, whatever I go in there as the inputs, and then it shows the output, what we are taken, and then it shows the table. So this is the truth table for the AND gate. So 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1. And then it also shows the expression. So expression will be always output, that is C will be equal to AB. So this is how basically we can implement the logical gates. And then to save the circuit, we have the file option. We can save this, and once we save this, also if you want to have a print, we can take the print. If you want to take the export image, we can take the image of this. So this is how we can implement the basic gates. So let us understand one more way of implementing this. So I will take one more example by taking on a file, and I will open a new project. So in this we will take one more way of doing this logical circuit and analyzing them. So I will take the gates. So suppose I want to implement a AND gate by using a NOT gate. Okay, so I will take a AND gate here. I will change the attributes. I will change the gate size to wide, and I will change the number of inputs. Number of inputs I will take it as 2, and then I will add wires to this. And then I will take the input pins. So there is one more shortcut is given to this. To add anything, if you want to copy it, you just use the Control D option. It will be copied, and then just place it towards the pin. So then I need an output wire. So I will take it as an output. Output wire here, and I will attach, since I'm implementing a NAND gate using AND gate with a NOT gate. So I will attach a NOT gate here, and then this will be attached to the output. So this is how I am trying to build the AND gate. Similarly, in the same fashion, you can execute this by taking the poke option. So 0 0 is already 1. If I change it to 0 1, it is 1 again. If I change it to 1 0, it will be 1. If I change it to 1 1, it will be 0. So this is how we can implement it. If I change this, analyzing this, instead of building the circuit, if I know the expression and if I know the truth table, I can also do that by using just going to the project option, analyze circuit, and here I can write the inputs. Like I will write the inputs as A, add the input variable, add the input variable as B. So I will write the output as Y, or any variable you can take, and then I will go to the expression. So expression is given as Y. So I will write the expression what I want. So I want this as, suppose for example, I want to have it as A dash B. So I can take it as this tilde is used for the inverter. So A dash multiply by B. So if I want to build this, I can use this. Then plus I want B dash A. Okay, so it is similar to what? A dash B plus B dash A. So or you can say A dash B plus A B dash. So it is actually the output of, we are building a circuit of a XOR gate actually. Then we can go to the option that is build circuit. So it will ask you use to two input gates only, then click S and then click on OK. So your circuit will be built automatically. But since we have not given the values for the truth table, it is not giving the proper output. So what we have to do is we have to go for the analyze circuit, and then we are given the expression, we have to change the truth table. So truth table we have to change it as for the XOR gate it will be 0 0, it will be 0, for 1 1 also it will be 0, and for other options it will be 1. So now I can say that build circuit. So it will build the circuit. So this is how without designing the circuit I can still manage to I can still design the circuit by just going for the project option and the analyze circuit. So this is how we can use the Logisim. Thanks for watching. Subscribe to my channel. Okay.
Okay, all right. So if you can't understand the words, no? So just follow na lang sa iyang gidemo, no? So mas substance man ang iyang gidemo compared, no? Kung naman gani mga unclear sana speeches, no? So okay ra ta? Isa lang nako ang link sa atong Google Classroom, so for you to view it again and again, and then pwede ra ta mo tan-aw og laing material. So basta kay ang importante maka-install sa taon na og Logisim sa atong mga laptop, no? You must include also JDK, Java Development Kit, kay para mo run ang atong Logisim. So anyway, di man siya kaayo bugat. So well, so far that's all for this week. Familiarization of both laboratory tools, no? Softwares and hardware, as well as the in relation to our lesson 2 or module 2 lesson 1, no? Proper, no? So any question for this meeting, guys? So that ends our meeting for this day. Don't forget to send me the screenshots for the attendance participants, as well as the I record this one for those who wasn't able to attend, but then tagaan lang nako og copy upon valid reason. So first of all, nangutan ako sa first batch nga meeting kisa tong mga ni absent. So naay mga iilan pud nga nagsan asay wala gyud, no, nagpakabana. So anyway, as what I oriented you, ikaduhang meeting or ikaduhang submission niya permita late, so di ta matinga o naay consequence mahitabo na after, no? So it's either be malain ka sa Google Classroom sa normal classes, or no, na ako'y buhaton pod nimo so soon, no? So okay, so that's all for today. Any concerns, additional concerns? So I'll just end the recording, stop share. Any concerns before we leave? Questions? Wala na?
Wala man siguro, ma'am.
Okay, thank you guys. Thank you for responding. Majority are here, no?
Thank you, ma'am.
Any version, so kanang mo fit in. So anyway, murag unsay mo pop up nga Java mo to i-install. The moment you unsay gi-choose mo gud nimo nga unaha lang siguro ang Logisim, nya mangita man siya Java. So katong nga question nga any kuan ba daw any version sa GDK. So isuway lang pod imuran ba sa inyong version, no? Sa ning 5 up step. Unsa to 5 up step? O kasabot. Sige lang, unahan download si Logisim and then kung di mo dagan, mo appear man na siya nga mangita siya GDK. So kung say mo appear nga GDK, try lang po dong install niya. The moment maka-open na ka na, automatic mo open na siya, no? Kung naka-install na si Java, no? Okay, try lang. Ayun ang kadlock, no? Free ra man sad ang software, free ra sad ang Java, no? Sige. Thank you. That's all for today. You may leave now.
Thank you, ma'am.
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 Thank you, ma'am.